Having talked about the blood and the heart, it's time to talk about blood vessels, blood flow, and blood pressure. So blood vessels in general, 60,000 miles of them. So the circumference of the Earth is around 25,000 miles. You can go around the Earth 2.5 times with just the blood vessels in a single human body. Unlike insects, which have an open circulatory system, humans have a closed circulatory system. So in insects, their entire body cavity is filled with hemolymph, which is a combination of blood and lymph. Their heart is just like a toilet paper tube. They just kind of go, and it just swirls all that fluid around. We don't have that. We have blood vessels. Our blood is contained within little tubes, and that allows it to take it more specifically to certain places. The insect model will work for insects. It wouldn't work for something as big as a person. Blood vessels are dynamic structures that change according to body needs, so they can, as you probably know, they can constrict and they can dilate. And you can also do things like shunt blood, all right? They pulsate, they constrict, they proliferate, so you make more. When you make new tissue, you make new blood vessels. They can repair themselves as well. When they're injured, we saw that when we looked at blood clotting. Things like a vascular endothelial growth factor will help them repair themselves. They're innervated by the nervous system. That's what can cause them to constrict and allow them to dilate. And some have their own blood supply, the vasa vasorum. Vasa vasorum literally means in Latin, vessel of the vessel. So some of the big giant arteries, like you can see on that far right diagram, they actually have a little tiny miniature blood vessel that takes blood to the artery itself. The artery is living tissue. It needs oxygen and glucose to stay alive, and so it actually has to deliver blood to itself, the vasa vasorum. Now, I want to show you two words here, dilate and dilate. So one of those is a word in the English language. It's a word in scientific vocabulary. It's used worldwide. The other is not a word in any language on planet Earth. In fact, it's not a word in any part of the known galaxy. So which one is a word and which one is not a word? Yeah, that's not a word. The word is dilate, not dilate. If you ever write down the word dilate on a quiz or an exam for me, that'll be an automatic -50. Because if you get out there into your profession and you say dilate, other people around you are going to whisper and they go, "What a dumbass. They said dilate." And then they're going to ask you who your A&P instructor was. And I don't want anyone to say my name. Anybody who says dilate will not say my name as their A&P instructor. You guys are all going to say dilate, not dilate. Okay, basic structure of a blood vessel. So arteries and veins, those are the two big kinds of blood vessels. They have a 3-layered wall surrounding a lumen. Lumen means the hollow space inside. Organs have a lumen. Your stomach has a lumen. Intestines have a lumen. That means the empty space inside of that thing. So blood vessel basically has the tissue around that makes the tube, but then the tube itself is hollow. That's the lumen. Lumen is lined by endothelium. All right, that's the lining on the inside. Blood flows within the lumen. Now, capillaries are a little bit different. They have simple squamous epithelium. That's their endothelium. They don't have the 3 layers, all right? Arteries and veins have 3 layers. Capillaries don't. They have a basement membrane in addition to the simple squamous epithelium. They have a very tiny lumen. No other layers. As we'll see, capillaries are where nutrients leak out, and waste products can leak in as well. So capillaries are special. Capillaries are intentionally leaky. You don't want that to be true of arteries and veins. So the 3 layers of the blood vessel wall, the tunica interna, in some cases it's called tunica intima. I don't make a big deal about the difference between those two. You can say either one in my class. That's endothelium and its basement membrane. Then tunica media, so interna was the inner layer. Media is the middle layer. That has smooth muscle cells in it. That's what allows for vasoconstriction and vasodilation. Then the tunica externa, sometimes tunica adventitia, again, I don't care about that difference, has lots of connective tissue like collagen and elastin that allows it to expand and to snap back so that it can pulsate. And then the vasa vasorum, again, seen in large blood vessels. They actually have a vessel of the vessel. So there's a little miniature blood vessel that goes to the blood vessel itself. Again, blood vessels are living tissue. They need oxygen and glucose, just like all other living tissues. There you go, nice diagram showing the 3 layers, all right? Both arteries and veins have the 3 layers, all right? And here, slides, photomicrographs, 1 millimeter. So there you see, look at in the upper left, you can see an artery. See how the artery has thick muscular walls? Then down below you see a vein. That's very characteristic. Arteries have a lot more smooth muscle than veins do in general. That's why arteries are generally the ones that can do the constriction and dilation, not so much the veins. And down in the lower diagram, you can see the same thing. L for lymphatic vessel, A for artery, V for vein. Notice again on the lower illustration, the artery has a thick muscular wall, the vein does not. All right, and then you see a nerve there as well, a lymphatic vessel. Okay, so let's talk about some arteries. They are vessels that carry blood away from the heart. That's always true, 100% of the time. All arteries carry blood away from the heart. They take blood to someplace else, from the heart to someplace else. Now, the systemic arteries carry oxygenated blood. However, the pulmonary arteries carry deoxy blood. Think about it. Your heart is pumping blood to the lungs to put oxygen into them. So, the blood that comes back from your body through the vena cava, all right, those go into the right ventricle and they are pumped to the lungs. That's the pulmonary artery that carries the deoxy blood to the lungs, okay? So that's one big exception. The fetal umbilical artery is the other big exception, because this is where the baby is sending the deoxy blood back to mom to put oxygen in it. So let's make this clear. All arteries carry blood away from the heart. That's always true 100% of the time. Most arteries carry oxygenated blood, with 2 exceptions. Pulmonary arteries and fetal umbilical arteries carry deoxy blood. Those are the only 2 exceptions. 3 main kinds of arteries. There are elastic arteries, which we also sometimes call conducting arteries. There are muscular arteries, which are the distributing arteries. And then there are arterials, which are the resistance vessels, all right? And arterials have the greatest effect on blood pressure. Put a big asterisk by that, make a special note of it. Most of your control of blood pressure, like when we talk about vasoconstriction due to the sympathetic nervous system, we're talking about arterials, all right? They're the ones that can really constrict down. They have a lot of smooth muscle, and that's what they do to help control blood pressure. Let's start by looking at elastic arteries. These are like interstate highways. These are the biggest arteries in your body. So we're talking about like the aorta, the pulmonary trunk, the brachiocephalic trunk, remember the one that goes up to your head and to your arm, the common carotids, all right, so going up to your brains, the subclavians, and the iliac artery, all right. These are arteries that take blood to like whole regions of your body. Very large lumen, more than 10 millimeters, that's 1 centimeter. That's a big damn artery, okay? About the width of my index fingernail, all right? That's how big that is. Lots of smooth muscle, but they're generally not active in vasoconstriction. And think about it. It makes sense. You wouldn't want them to. Since they're controlling blood to whole regions of your body, you don't want them to constrict down and limit blood going to the brain or, to organs and so on. So you don't want them to constrict down for the most part. They have lots of elastic tissue so they can expand and recoil. And that's really what the pulse is. When you feel a pulse, you can feel these arteries. Like, a lot of people who work out, you can check your pulse by feeling your carotid artery. You get a big, huge pulse in your carotid artery. It's easy to feel. That's because it has a lot of this elastic tissue. It can expand and recoil. So that's also helpful because the pulse actually helps to push blood along. In other words, the elastic arteries will expand. When the heart beats, there's a big burst of blood that goes into these arteries. They will expand, and then when they snap back, the elastic tissue snapping back actually helps to push the blood further along. So They are actually helpful in getting the blood out to your body because of their ability to expand and recoil. What can go wrong with elastic arteries? Some pretty important things. So arteriosclerosis is a blood vessel wall becomes hard and unyielding. Like I've said many times, as you get older, things that are supposed to be stiff get floppy, things that are supposed to be floppy get stiff. You want arteries to be kind of floppy. You want them to be elastic to be able to do that. Instead, as you get older, a lot of the arteries can become stiff. That's arteriosclerosis. You lose that recoil effect, that expand and recoil, all right? So you lose the pressure smoothing effect, and as a result, that leads often to higher blood pressure. Walls of the arteries throughout the body will experience higher blood pressure because of that. And the high blood pressure can weaken arteries over time, causing leakage and aneurysms. So an aneurysm is a weak spot in an artery, right? So, and if the weak spot is there, that means that the artery can start to bulge, all right? It's no longer capable of holding the blood in very well. It starts to bulge out. You can see in the lower right diagram there, a thoracic aortic aneurysm and an abdominal aortic aneurysm called a AAA. That's where a weakened artery over time is now bulging outward. That is an aneurysm. Blood vessel can balloon out, and there's an increased risk of rupture. So the abdominal aortic aneurysm, man, when those things burst, nothing can help you. All the king's horses and all the king's men really can't do anything for you. Suddenly, blood that's going to be just draining into your abdominal cavity, and you're going to lose blood pressure, you're going to lose blood to your organs, and there's really nothing to do to help you in that case. You can also get brain aneurysms. That's where a weak spot in an artery eventually can rupture, and in that case, that's what a stroke is, all right? So there you see. That's a stroke. You've got a little weak spot. It balloons out over time, and then one day it bursts. And that was my uncle. My uncle woke up one day. I mean, he was only in his 40s. And he came out to the kitchen and he said, "Wow, I got a real headache." My aunt said, "I'll go get you an aspirin." And she came back in. He was lying there dead on the floor. He had an aneurysm in his brain that just burst suddenly. Massive stroke, and he died right there in the kitchen. Which statement is false? The walls of arteries and veins have 3 layers. Elastic arteries are not active in vasoconstriction. All arteries carry oxygenated blood away from the heart. Arterials have the greatest effect on blood pressure. Pulmonary arteries carry blood to the lungs. So 4 of those are true. 1 of those is false. Yeah, not all arteries carry oxygenated blood. Most of them do. There are the 2 big exceptions, the pulmonary and the fetal umbilical.